After the almighty algorithms started to surprisingly recommend my maths videos to hundreds of thousands of people, I was thinking for months about the next episode of this unofficial sub-series. But whenever I had an idea, it turned out to be too obscure or too complicated for me to understand. Hopefully, this will not be the case for Quaternions, which include some peculiar rules. Back in school, we didn't really leave the realm of real numbers, at least in my case. They were described kinda like a set that covers every possible number. After all, what can be opposed to real numbers? Unreal numbers? Well, sort of, although the name is a bit different: complex numbers. So what exactly are they? Instead of a single real number a, complex numbers are a sum of a and bi, where a and b are real numbers and I is the tricky part called imaginary unit. Its crucial defining property is that I squared equals -1. But wait, how is I squared being -1 possible? It just is, okay? We just need to treat I like an unknown quantity while manipulating expression, as real number operations are still completely valid. The naming is also very confusing. Imaginary unit I and imaginary numbers bi are in no way worse or more abstract than real ones. This unfortunate term was coined by no one else than René Descartes himself, back in the days when imaginary numbers, and therefore complex numbers, were seen as abomination with no practical purpose. But knowing that, for example, zero and negative numbers also were initially seen as abominations, one could expect a rise of complex numbers and justice for them all. To make it more approachable, the easiest way to think about complex numbers is to present the sum using two axes. To the so-called regular one for real numbers, let's add a second one for quantity of imaginary units. Then we place our a plus bi number as if we're using Cartesian coordinate system. If we keep it this way, multiplication by I means a counterclockwise rotation by 90 degrees about the origin. Okay, for now I kept talking about complex numbers and not quaternions. Let's change that. Quaternions are an extension of an idea behind complex numbers. Instead of just a plus bi, quaternion is represented as a plus bi plus cj plus dk. A property of I squared equaling -1 is also true for j and k. And a product of I, j and k also equals -1. ijk equaling -1 feels weird, but we'll get to that later. Unlike complex numbers, quaternions have a real father. They were first described by Irish mathematician William Rowan Hamilton in the middle of the 19th century. Side note: apparently Carl Friedrich Gauss himself discovered quaternions earlier, but his work was not published before 1900. So he may be a godfather, but he's basically a godfather of everything that's maths related. So let's go back to Hamilton. He was aware that complex numbers can be presented on a plane and that a 2D rotation was playing a key role in understanding them. He kept pondering, what about 3D rotations? Convinced that there has to be a construct for those, he worked for years on the sums of three components, a plus bi plus cj. However, the maths wasn't mathing, and Hamilton was left stranded. Then, on 16th of October 1843, Hamilton had his eureka moment. He was walking along the Royal Canal in Dublin with his wife when he realized that the key is to include 4 components in the sum, as 3 are simply not enough. He was so excited that he carved the formula in the nearby Broom Bridge. The carving didn't make it long enough for us to see, but today you can find there a commemorative plaque instead. It was a breakthrough for Hamilton, but it didn't mean the work on it has ended. You see, adding a fourth component doesn't change much in terms of addition and subtraction, but important change in Quaternions is that multiplication is no longer commutative. For example, I times j is not equal to j times I. In fact, I times j is equal to minus j times I. ij is also equal to k, so our earlier equation ijk equaling minus 1 can be presented as k times k equals minus 1, and therefore k squared equals minus 1. And now here comes the everyone's favorite question. What are Quaternions for? After the 19th century, Quaternions were losing on their popularity after initial Hamilton's success. But thanks to recent technological revolution, they are going through their revival period and are stronger than ever. Basically every contemporary 3D computer game involves Quaternions as a tool to map spatial rotations properly. There are some alternatives, of course, like using 3x3 matrices, but Quaternions' compactness and swift calculation are simply more handy. Also, rendering 3D rotations is prone to some strange bugs and a so-called gimbal lock. Because it's difficult to explain those in one sentence, I will link the videos of creators who are explaining those issues very well. But the most important conclusion is that the use of Quaternions eliminates those issues. And 3D games are only scratching the surface. Think of robotics, for example. Implementation of movement in 3D space is almost guaranteed to use Quaternions to some extent. Same can be said for rendering resonance images, computer simulations, molecular dynamics, spacecraft attitude control, or everyone's favorite topic, quantum mechanics. Those are strongly practical uses, but trust me, Quaternions are also valuable to some advanced math problems, theories, and scientific approaches. So what's the moral of the story? Well, don't undermine imaginary numbers. They are as real and amazing as others. And if you're stuck on a problem and you don't know what to do, just take a walk. As do people during the annual pilgrimage called Hamilton Walk, when they go and embrace Quaternion plaque on Brook Bridge as a way to pay respects to an outstanding Irish mathematician. I hope I'm gonna see this plaque myself one day. If you enjoyed this video, don't forget to leave a like. Let me know if you're interested only on maths topics or you're also craving for more general, unusual stories. And if you're driven by curiosity like me, you can watch my previous video about the producer of an Oscar-winning movie that was competing in a triathlon with a broken shoulder in order to make the film. Anyway, thank you for watching and have a nice day.